evaluate this integral, double integral, in the region R, where R is bounded by the lines here. So let's graph this region R. X equals 0, that's the y-axis. Y equals 2x here, and y equals 2 minus 2x. This is 2 minus 2x. So this is the region bounded by these three lines, that's R. Okay, and we can make this like, if we draw a horizontal line here, then we can divide this into two type 2 regions. But look at this integrand. This is 4x squared minus y squared, quantity squared, so it looks complicated. And we have to make appropriate change of variables. So I want to work on integrand and come up with the substitutions or change of variables. Okay, so integrand is 4x squared minus y squared, quantity squared. Inside this is a difference of two squares, so this is 2x plus y, 2x minus y, and we have quantity squared. That means they square both. So if we let's say this is u, 2x plus y, and v, 2x minus y, then this becomes u squared times v squared, and we can easily integrate that. Okay, so we let u be 2x plus y and v be 2x minus y. Okay, in this way integrand is just easy, u squared times v squared. Now we want to convert this region to new region with these change of variables. Okay, so look at this line, y equals 2x. This is same as, if we move around, this 2x minus y equals 0. Okay, this is 2x minus y equals 0, and this is same as 2x plus y equals 2. And the new region will be then, and we know 2x plus y is u. So this 2x plus y equals 2 is in fact u equals 2, and u be plane, so u equals 2. So this is u equals 2, and this is v equals 0. Okay, v equals 0 means u axis. It's like y equals 0. Okay, v equals 0 is u axis. Now we need to know what is this line. Okay, about x equals 0, this part. To convert this x equals 0 line, so let's plug in here, okay, in our substitutions. So we get u equals 0 plus y, and v equals minus y. This is same as negative v equals y, and these y's are same, that means u equals negative v. It's like x, y, let's write in terms of y equals something, so multiply both sides by -1, we get v equals negative u. This is like y equals negative x, and let's graph that. So this is v equals negative u, and here 2, so this will be negative 2, this point is 2, so this is the new region, and we can call S or D. Okay, this is one way to convert this region into this, or we could have figured out the point of intersections here, this point of intersection here and here, then those xy, xy, xy plug in here, we get corresponding uv, 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 and that would, in that way we would have found these 3 points as well. Okay, so next we need to find the Jacobian. Okay, so for next we need to find the Jacobian, that is partial xy in terms of partial u v, that is find partial derivative of x u v, partial of y with respect to u v. Okay, so now it's not given, so we need to do one little work. So solve this equation for x and y. Okay, solve for x and y. Okay, so let me do over here. So we have here 2x plus y equals u, 2x minus y equals v. If we add these two equations, these two cancel, we get 4x equals u plus v. So x equals, divided by 4, 1/4 u plus 1/4 v. Okay, in the same way, now we can plug this x into one of these two equations and find y. Let's plug in the first equation. So we got first u equals 2 times x, 2 times this, so 2 times 1/4 is 1/2 u plus 1/2 v plus y. Subtract 1/2 u, 1/2 v from both sides, u minus 1/2, so 1/2 u minus 1/2 v equals y. Okay, so we have x and y, so we can find this Jacobian. So partial of x with respect to u is 1/4, with respect to v 1/4, for y partial with respect to u 1/2, negative 1/2. If we multiply, this is negative 1/8 minus 1/8, it's negative 1/4. Okay, so the Jacobian is negative 1/4. Thus the given integral is, now we can write in terms of new region, which is, we said yes, and that was integrand. We work with this and we are assuming u v, so u square v square, absolute value of Jacobian, absolute value of negative 1/4. Okay, our Jacobian is here, absolute value of negative 1/4 is just 1/4, and this area, okay, dA, which is, now we can consider this as type 1 region. That means u can run from negative 2 to 0, and v is negative u to v equals 2. Okay, so this is dv du, and u outside, u from, I mean, you can run anywhere, these arrows negative 2 to 0, and v lower curve, that's negative u to upper curve, that's 2, and we have 1/4, we can pull all the way outside, in fact, u square v square. Okay, and it should be simple enough to integrate. Okay, I'll integrate here. So just do the integration here, regular integration, upper limit, lower limit, distribute, integrate, plug in upper limit, lower limit, and simplify. So the answer will be 8/9 final.